So, Jain to all of you, myself Dr. Jaishree Jain, Associate Professor in CSE Department in Ajay Kumar Garg Engineering College, Ghaziabad. So, today we will learn about the convolutional neural network. That is the topic in deep learning. So, what is the meaning of convolutional neural network? Basically, we have already studied the neural network term, and in which we have to classify our data. So it will support linear as well as non-linear data set. So now the term convolution have been used in this because the data can be of any type, such that data can be in the form of text, data can be in the form of images. So this neural network we will use for image classification, for image object detection. So this approach will be used for classifying, generally used for image classification. So what is this convolution neural network? So we can see one of the most impressive form of artificial neural network architecture. So its architecture is same like we use in neural network. We have input layers, we have some hidden layers, and we have output layer. So in this convolutional neural network also, this is a layered architecture in which we have different layers. So we can say it is having the layered architecture, and CNN is used to solve the image driven pattern recognition task. So generally we used for image classification, and CNN is has one or more convolutional layers. So I already told we have also connected layers used in CNN, and if we all know for processing the image we need some image segmentation algorithms and also other autocorrelated data. So how it is used? So we can say we have to label someone in the images, like in Facebook we tag the faces and it will identify the person. So Facebook already using the CNN network. So we can say CNN is very important and have the connected layers so that we can identify the images, and we can identify the object from the images. So this is the example. If we have this image and we are seeing these are the objects. So how can we detect when we point to these faces? So it will show the identity. So this is the example. Facebook already using this CNN network. So we can identify who is the person. So this is the example, and this is another example. If we have this image, cat image, and in this image we all know what image have number of pixels. So this is the matrix, 2D matrix of this pixel. So we have identify the based on some feature, because we have to extract some feature. So this pixel have some important feature, so we have extract this. So this is the pixel value, intensity value. Actually pixel have the intensity. If we are using grayscale image, so intensity is 0 to 255, and if we have RGB image, then the image is 3D, and there are three channel red, green and blue, and intensity vary from red channel 0 to 255, similarly green channel 0 to 255, similarly blue channel 0 to 255. So after classifying we have to apply some CNN and any model, so that we can classify the image that 82% is cat, and we can classify that 15% is dog, 2% is head, like that. So it's very important to identify if our data set is in the form of images, so that we can identify which image is of that denote to. So we have to identify the image, and for which we need one network that is known as convolution neural network. So we can say convolution neural network or CONVNets. So short form is CONVNets. So CONVNets are the neural network that share their parameters. So actually it have a layered architecture, and the output of previous layer is the input for the next layer. And for example, if we have the cuboid having length, width and height of the images. So if we have this colored image, so we have three channels. So this height, width and the information length, width and height of the channels will also contain three model, because this cuboid is for red channel, for green channel, and for blue channel. So how we apply this convolution? These are the layers that are used in convolution. Like first layer is convolution layer, second layer is activation layer, then pooling layer, and then fully connected layer. So these 4 layers generally used in CNN, and at the end we get the fully connected layer. We have set of vectors, and after that we have applied the activation function like softmax, which will convert these vector in the form of probability. So we can predict how much probability is that image belong to cat image or dog image or any other image. So this is the architecture, and in convolution I already told this is used for image classification. So these are the some application. Convolution is used in signal processing and is a mathematical approach that allow two signal to be combined. So how it work basically? So this is the process. If we have image have 2D matrix form. So this is a 2D matrix, and we have to apply some kernel or filter here. This is the kernel. We can say this is kernel or filter. So this kernel have some window size like 3 by 3 size is there, and this will be overlap. This will be convolved in this original figure image, and then we will get the new pixel value. So this is the first step, convolution layer. So here this is the process. If we have 3 by 3 filter or kernel, and this is the image of 5 by 5, sorry, 5 by 5, and kernel size is 3 by 3. Then we apply this kernel to this window 3 by 3, and just form the convolution form. Like we have dot product of these. So at 1 we have here I already written 1 into 1 plus 0 into 1 plus 1 into 1 plus 0 into 0. Like that we will apply the dot product of each filter element with image element, and then sum all the value, and the center pixel will get replaced with that value. So this is the procedure of the how this is called as convolved feature. Fine. So next is first layer is convolution layer. Then we will slide other window, and like that 3 by 3 window, then other window. So we will get the output like this window, like this. So like that we slide the window and convolve the feature and find the final convolved feature, like that. This is the other example. Like if we have one dimensional array and we have filter element this, then we can slide this 2 by 1 array to this window and find the convolved features. So this is example. We have 6 by 6 image and 3 by 3 filter, and finally we will get 3 by 3 4 by 4 matrix. If after convolution we will get 4 by 4 image, the first element of 4 by 4 image will be calculated as this. So I already told how convolution work. We have to calculate the dot product of filter element with image element and sum all the element and replace that element with the center element. So here one thing is that there is a problem if we are using this. So this corner element, this corner pixel will not included actually, because we are replacing the center pixel. Next time this window is selected and we are replacing the center pixel. So first row and first column will not included in convolution feature. So how can we prevent this problem? By applying the padding. So we can apply the padding bit of 0, so that we can apply the one row and one column here with padding bit, so that when we select the center window, then this element will also considered in the convolved feature. So this is the logic to prevent the corner element eliminated. So we can apply the padding bit here. These are the some pattern if this is the image, and how can we choose which filter we have required. So like if we are using this 1 0 1, 0 means this is gray and 1 means white and -1 means it is black, then we will get this. So this is the application if we want to change the contrast of the image, and some edges should be dark and some brightness should be there. So we can apply different filter and can change the brightness and contrast of the image. So we have different filter like vertical filter, horizontal, oval filter and scar filter. So depending on our need, we can apply if for example this is the image and we want to detect the vertical edges from the image. So for detection of the edges, we have to apply the vertical. For vertical edges, we have to apply the vertical filter, and for horizontal edges, we require the horizontal filter. So it depending on the requirement, we can use different filters here. So these are the different metrics of filter. According to the application for edge detection, we can choose these filters. For identity, this is the identity means actual image will get after convolved feature. For sharpening, we can choose this filter, and for box blur and for Gaussian blur, these are using for blur the image. So depending on the application, we can choose any kernel and apply on the original image. So I told the concept of padding because if input size of image is n by n and filter size of image is f by f, then output will be n minus f plus 1. So here the V loss, if the image size is n by n means 6 by 6 and filter size is 3 by 3, then output image will be 6 minus 3 plus 1 means 3 plus 1 means 4. So 6 by 6 image will be converted into 4 by 4 image. So we have to prevent this, and we want that after convolution we will get the actual size of the image. So we have to apply the padding bit here. So after padding bit, the output, the size of output image will be n plus 2p minus f plus 1. So this is a padding bit we apply here, padding of column and padding of row in RGB channel, like that. So next layer is pooling layer. In pooling layer, we just try to reduce the number of parameter or size of our activation map. So for this, we have to apply two pooling layer, two pooling types are there, max pooling and average pooling. So calculate the maximum number of element. Maximum element means how, I will explain this with the help of example. So this is a after convolution, these are the convolved feature, covenant or convolved feature. Then we will have apply max pooling here. So we will just, firstly we have to select the pool size 2 by 2, and then if we are selecting 2 by 2 size, then if max pooling, we have to find the maximum element. So maximum element here is 100, here maximum element is 184, here maximum element all are equal means 12, and here is 45. And if we are using average pooling, means we have to select the window size and do the average of the element. So for this we have to do the average of these elements. So this is the answer of the average pooling. So this is a structure. If we have input layer means original image, then we have applied the different kernel or filters. So we have applied here 1, 2, 3, 4, 5 filters. So first filter is horizontal, then vertical, then diagonal filter, and after that we have applied the pooling layer, means max pooling or average pooling. Then again we are applying the filters. So filters are in the form of this. This filter we have applied, and after that we have applied the pooling layer. So this is the process. So we can apply multiple filter and can pool multiple times. So this is the example of size. If the original size is 39 by 39 into 3, because we are using RGB channel, so we have 3 channel, red, green and blue, and here we apply 10 filters. So 10, after applying 10 filter or convolution, we will get this size. Then we have applied 20 filter, fine. So we have, this is a reduced because we have applied the pooling layer, and we have applied the filter and we have applied the pooling. So this is the calculation of size. So n plus 2p minus f upon s plus 1. What is this s? S means stride. Stride means we have to select the window size, the dimension of the for sliding window. So if we are choosing 2 by 2 max pooling with stride 1, means if we have selected this window 2 by 2 pool size and stride is 1, means next time we will left 1 column and then stride here, then left 1 column, stride here. Fine. And if we stride is 2, means we have to left 2 column and the stride size will be starting from here, filtering or window sliding size. So this is the example of how we choose the stride. So if stride is 1, means 1 column will be left for sliding window. If stride is 2, then 2 column will be left and then 2 row also will be left when we are selecting this. Next time, if stride 1, then we will choose this one. If stride 2, then we will choose this one. So this is depending on the stride size, we have to slide the window. So this is the example. Suppose this is red, green and blue channel and we are applying 3 filter for 3 channels and then we will get the convolved matrix, convolved features. So first element of the output is sum of element wise product of first 27 value, because the matrix is 3 by 3 means 9 into 3 means 27 input values and 9 value from each channel and 27 value from the filter. So after we convolve over the entire image. So this is the output 4 by 4, then we have apply again 3 into 3 filter, then 4 by 4 convolved feature we will get. So this is the final formula for output image. N plus 2p, p means for pooling, padding, and then S means stride size. So this is the final output size of the image. So already I told input layer means the layer raw input of the image of width 32 and height 32 and depth 3. So this is the one example. Then convolution layer. Convolution layer means dot product of filter and the image patch. So if we use total 12 filter for this layer, we will get output volume is this. Means 32 by 32 is image size and 12 filters. So image size is this. Then activation function will be applied here. So we can choose any activation function like ReLU. This is the formula of ReLU. Activation function means rectified linear unit, which graph just like that because it have negative value 0. So all negative value of x get 0. Then x maximum. So what will be the value of x? Correspondingly, we get the value of y. This is the graph of ReLU. So sigmoid, the graph of sigmoid activation function is like that. So this will have the threshold value 0.5 here and have, this is the formula 1 upon 1 plus e raised to power minus x. Then tan h activation function, leaky ReLU function. So the volume remain unchanged because we are using only activation, means we are trying to fit our data into that this model because we have to classify the image. So the irrelevant feature will get removed and activation means we just try to find whether the input will fire or not, means it will match to any class or not. So independent variable will be can be classified to the dependent, means dependent variable we can find the value from the independent variable. So we have to choose some activation so that we can find out which input can match with the output layer or classification layer. So next is pooling layer, and pooling layer, max pooling and average pooling I already told. So we can apply some pooling, and after max pooling with 2 by 2 filter, with 2 by 2 filter the size will reduce and dimension will be 16 by 16 because it get half 32 by 2, 32 into 32 divided by 2 by 2 pooling layer. So we will get the output 16 by 16 and 12 will be the filters. 12 is the size of filters. Clear? So after pooling layer the size got half. So we are using full pooling layer because we want to reduce the redundant element, redundant feature, and will reduce the pixel size of the image. Fine. So next is fully connected layer. Fully connected layer means when we do this process regularly, then after that we will get the fully connected layer, means one dimensional array of elements, one dimensional array of image. So only 1D element will finalize and fully connected layer, and then we apply some activation softmax function to convert it into some probability, so that we can find out the possible chances and find out the particular class like 0 and 1. So this is the activation functions I already told. This is the graph of sigmoid, this is the graph of tan h, this is the formula of tan h, e raised to power x plus e raised to power minus x upon this. This is sigmoid function and this is ReLU function. So these are particular activation function we will choose to reduce our features. And this is the example. We have original image, input image, then convolution layer, then we have applied some pooling layer, then convolution layer, and after that we get the fully connected layer, one dimensional array, and apply softmax function. So probabilities will be 0 or 1. We can round off the probability and find the particular class. So these are the example. We have 2D image, we have, these are the filter, then 2 by 2 max pooling, then it will reduce to half size, and then we have applied convolution layer on 40 neurons, 1600 kernel total. So 40 neurons are there, these are 40, and we have applied some, this is the activation function. Activation function have been applied, and at the last we get the fully connected layer, and we'll apply softmax function and find the output of the this image. So this image, finally we get this image, and then we can classify what is the matching of this image with our database. So this one I already told, and this is the softmax function, and this is the formula for softmax function, e raised to power yi upon summation e raised to power yj. So if we get the fully connected layer element, then we apply softmax function and it is converted into probability. 0.7 means we can round off it near about 1, and 0.1 means we can convert it into 0. 0.5 can be threshold. Fine. So this is the final understanding softmax function. If we get, this is fully connected layer, and this is the, we convert it into e raised to power 5, e raised to power 2, e raised to power minus 1, and e raised to power 3 for calculating the probability, and then apply the softmax function. So for first element it will convert it into, the formula will be this one and sum of these all element, then e square sum of these element, e raised to power minus 1. So we will get the probability, and if the threshold is 0.5, this will round off to 1, and all will get the 0. So this is hardmax, and we will finalize the class which class it belong to. And finally, at the last we can find the loss function with these probabilities. So thank you so much. This is all about CNN and how can we classify the images, and at the end how can we find the loss function and calculate the accuracy of the function. Thank you so much.